Hi, I'm Timothy Spam. Today I'm going to be talking about using the FLiPN stack for Edge AI. That's a combination of Apache Flink, Apache NiFi, and Apache Pulsar, and that's what we'll be showing you today. I have a few slides to start off, just a little background on how you can get in touch with myself and David. David's on the chat and answering questions today. If you want to get in touch with us, here's our Twitters, here's our GitHub, here's LinkedIn. Very easy for you to follow, and we'll have the slides available later. The first thing I want to show you is where's the best place to run the FLiPN stack, whether it's edge devices that need to communicate with it or something else. Using the Stream Native Cloud lets you get up and running right away, as all the management, all the security, all the features that you need without a lot of heavy lifting getting this set up. And it's set up for you in the cloud using all those native connectors, running on Kubernetes, and has Flink SQL ready to be built right alongside Apache Pulsar. So you can run a full flip stack there. Today, I'm going to walk you through some example FLiPN Edge AI apps. So this is a diagram of the entire end-to-end stream, which includes, like we mentioned, Flink, Pulsar, NiFi, some devices, and a couple different languages out there for producers. So I've got some NVIDIA Jetsons, I've got an NVIDIA Xavier, I've got a Raspberry Pi with an environmental sensor, I've got some sensors, I've got some cameras, I've got, some decent horsepower at the edge. So I can run some deep learning right there. That's often with Python. That's what typically these applications are. They could be C or C++ as well. What's nice is we have drivers for those devices in those languages. And I'll show you some examples in Python and Go. Something more important when you're working at the edge is often I can't put a library out there. I can't put something else. I may already have to send to MQTT. I might have to just do web calls or REST calls or WebSocket calls. Maybe I can call to Kafka. It's a mismatch. You never know what you're going to be able to do from these devices. Fortunately, Apache Pulsar makes it pretty simple. I can use, and I'm using example producers for other libraries because Pulsar can be enabled to use those protocols. So I've got MQTT on, and MOP lets Pulsar act as one of those MQTT brokers. So I just send messages to Pulsar as if it was an MQTT broker. Makes it very easy, very common use case for edge apps. So if that's what you want to do, you don't have to change anything. Just stream those on there. Maybe you have to change the name of the topic and what the broker IP address is or name, not a big deal. Now, if you already have applications that are sending things to an NiFi gateway, that's also not a problem. NiFi, as I mentioned with FLiPN, has connectors out there from David to push right into Pulsar, but also remember, I can push through one of these other protocols. So if I need to push through JMS or WebSockets or Kafka, I'll just do that. So, you have a lot of options. There's already a ton of different clients out there if you want to just call one of these client apps, whether it's Go, Python, .NET, Scala, and all of them you could think of are out there. So I get this into Pulsar, and this is great. Not only is it a place that I can geo-distribute my data, talking to people who love Pulsar every day, all those features there, being able to offload storage, and then being able to connect to Flink. Again, Flink plus Pulsar, great. Add NiFi when you need to get stuff in or out of there that maybe there isn't a driver already, or maybe you don't want to write or compile any code. NiFi fits in there nicely. It may already be in your infrastructure already. Maybe it's it there as an edge gateway along with MiNiFi, or maybe that's further down, maybe after Pulsar. It can also be a consumer, consumed from Pulsar natively or through one of the other protocols. Gets that data and can put it into various syncs. Also, I'm using some of the Pulsar syncs to do the same thing. That's a nice thing here. You've got that flexibility to decide, how do I want to get data where it needs to go? You know, can I wait for a batch? Can I do it right away? Can I wait for offloading? You have a lot of options. And, you know, we show you some of them. Some of them I'm sure you're familiar with already. So to make it a little more distinct here and show my fancy logo. What is Flip? What is FLiPN? Sometimes I'm just using Flip because I don't always need NiFi. Flink and Pulsar together could solve pretty much most streaming problems. So Flink, which is great, especially for the Flink SQL to do continuous SQL. Pulsar, I don't have to tell you about that. Stream Native has a nice Flink connector out there that just getting improved constantly. NiFi, in case I want to use it as gateway or conversion. I'll show you some of the reasons why NiFi really makes for a better stack. And then all the other things in Apache. Sometimes I need Tika. Sometimes I want OpenNLP. There's a ton of Apache libraries out there, Spark. And you could spend 4 hours listing Apache projects which are helpful, which would really fit into this stream here. I know as Pulsar people, you may not have familiarity with NiFi. Maybe you have. You might have seen me around talking about Apache NiFi. It has made my job a lot easier. You know, having guaranteed delivery, built-in data buffering, built-in back pressure, all these things configurable, all these things extensible, all of it open source, huge community, very stable. NiFi's been out for a very long time. Be able to prioritize your queues, adjust your quality of service, having that lineage data provenance to be able to see what's going on end to end, plug that into something like Atlas, and also get all that metrics from Pulsar. So you know where your data is in the world. That's important. Being able to push and pull data in, you know, maybe list from an SFTP site, maybe push to TCP/IP protocols, grab logs, tail files, you know, run deep learning. I can run deep learning in NiFi. That's something to think about when you're doing that edge AI. Yeah, maybe you have a Jetson that's got a nice GPU or you've got some custom TPU on there, but you don't want to do all your deep learning or machine learning at the edge. You may do it in stream, and that could be in NiFi, in a Pulsar function, in Flink SQL. When it comes out the other end, maybe it's Spark, it's NiFi, it's Flink again, it's another Pulsar function, it's a Pulsar consumer. You could plug in apps with deep learning anywhere in this process. Determining where that should be, can it be in multiple places, is a discussion that really depends on speed, size of the files, what you're doing, what the models look like, how often they're updated. If you want to discuss that, talk to me and David. Would love to go through your use case. Lots of processors there. Nice thing about NiFi that I don't want to gloss over, it's visual. I could certainly do things with the command line interface and REST, but having a quick and easy to use web UI to just drag and build your flows, really nice. Very extensible, version control cluster, scales out to hundreds of nodes, petabytes of data, millions of events. Great part of this streaming puzzle, and I'm flipping excited about it. Flink. Before Flink, you know, Spark has a lot of great uses, but Flink has some as well. Flink has been designed from the ground up to do streaming. It could do batch, but it's stream first. It could do really good stateful processing, especially when you start building up big aggregations, having a decent amount of state that you've got to track over time. This is great. And that connector, whether you're going into Flink or coming out, Pulsar and Flink work really well together for really fast, performant, scalable applications. Been able for me to be able to query against Pulsar topics and insert data into these topics through a nice SQL interface is great. This lets me do my streaming analytics, continuous SQL, complex event processing. That with Pulsar, I could write some really interesting microservices and apps. And if you're wondering how good is this SQL, if you haven't seen Apache Calcite before, you've probably used it. It's used in Apache NiFi. It's used in Apache Phoenix. It's used in Apache Flink. Ton of different great systems use it. It is full SQL. You can do some pretty amazing stuff here. Like I mentioned, that connector's out there. I'm sure you've seen it. I don't know if you've tried it out yet. Stream Native has this running in the cloud. It's pretty straightforward. If you want to do it through Apache, I've got some links. There's some articles out there. Pretty easy to set up. Runs really well. You could use the SQL gateway or use Stream Native's Cloud Console to do it. It's just nice. It connects it together really good. Now, I wanted to make sure I knew when to show you the demo. Hopefully I made that text big enough. There'll be some links here and some takeaways. So if you want to build these demos on your own, there is potentially a giveaway out there for some NVIDIA device here, but I don't know when that's happening. That could be happening immediately, or you might have already got it. Definitely check these devices out if you can get one. Makes for some nice Edge AI apps. So let's go through the demo real quick. In the cloud, I've got my topics already built. What's nice about that is because I also have a Flink cluster here, it set up all these tables for me based on those topics. So I could just look at a couple of them that I'm sending IoT data to, and I could see all the fields in there, all their metadata very easily. So I know, okay, what fields are they? So I could just write my query here. Maybe I'm just grabbing a couple of fields of interest. Maybe I'm only concerned with a few points, and then, just run my query. If you've done any SQL, which I imagine you have, that'll look familiar. Pretty easy to run that. And it's just running, depends how you want to run it. And then I've got data in these topics already, just to show you what's in there. Pretty standard JSON. I like to work with JSON from devices. It makes it easy to manage. It's pretty close to human readable, very easy to store in a topic, get a schema off it, run queries on it, interact in different ways. Pretty straightforward. And what's nice here is schemas and the version controls handled for me. I don't have to think about it. That is very nice. I've come from places where I've had to do that on my own. Here it's just done for me. Very nice. And we also have some similar data from another device I have out there. If you look here, this is running a different NVIDIA. They sell one with a little less RAM, which is still really good. And I've put an environmental sensor on there. Very good way to do it. You got a couple gig of RAM at the edge, do pretty good stuff. So let me make sure all my devices are running and ready to go. This is all running in my little office here. I wish I was in Europe with you. And we just run this device, make sure all my devices are running, whether that's producing data, consuming data, sending data, whatever these are doing. These are grabbing data from different locations. This is a Go app. This is a Go app. This is a Python app, running those sensors and then pushing them out to a file, and then someone is reading the file. Here I'm running stuff against this camera that's right to the left of me. It's taking a picture of itself here. Spider web, interesting. So that's what we got on the edge. That's what it thought. And then it sent that information as part of JSON with some IoT markup and sent that to a topic to read. Some of that is going into my cloud and some's going into a local cluster I have here. I don't have them geo-replicated yet, but maybe that'll be part 2. So there's a lot of data flying around here, whether it's off of cameras, off of sensors, getting combined here. I want to show you how I'm consuming that in NiFi. Thanks to David, I've got easy to use NiFi processor to consume that data. Pulling from this topic here, if you'll notice by the name, I didn't try to hide it. This is data that's coming from MQTT. This is coming from that Raspberry Pi over here. And you can see all the different sensors that I'm grabbing there. It grabs it from that topic, but by the time I'm consuming it, you know, I threw off the illusion that it's MQTT. Let me do native Pulsar here. And as you can see, data is coming in. It's a few records a second. And I can look at the provenance here, the lineage, to see what this data is, make sure it looks valid. I can look right in the JSON. This one was empty. So that's not good data because I did a conversion here. I'm looking at the data when the humidity is over a certain point. I might have to run an alert here based on that. Here I'm pushing this data to PostgreSQL. Again, you can send it anywhere you want. The beauty of NiFi, ton of different syncs here, whether it's AWS or Azure or Google, you know, wherever you need to push it, you know, Mongo, you know, different data lake storage, different JDBC stores, anything in the big data world. Nice use case there. For the use case of deep learning, now I've got all those camera images here. I could just use them for the analytics and throw them away. That seems wasteful. So one of the nice features of NiFi is I'm going to connect to that NVIDIA device, do a refreshing FTP off it, and grab images off a directory where it's capturing them. And then when I get them, I pull them in here. I've written a processor in NiFi to run the analytics on them. And then I push them to a Slack channel with the results of the analytics and the actual image. So I took a picture of my screen and then analyzed it, sent it up to the system, set the results down here. It's on my monitor. It's a monitor. Tried to put a box around it, did a pretty good job. Hopefully you saw and liked my little demo there. If you're interested in more content, please take a look at the links, look at my blog, and enjoy the rest of your time here at the summit.